Okay, we're looking at this video at the solutions to AS1 2023. This is a pure maths module. So the first question is to get started. The first question says solve the simultaneous equations. So here we've got one quadratic and one linear, and you can see I've labeled them equation 1 and equation 2. What you would do here is rewrite your equation 2, the linear equation, making y the subject. So it just becomes 3x minus 2. Then what you want to do is substitute that into the first equation. So it will become x squared plus 2 times, and instead of writing y, you're going to write 3x minus 2 is equal to 12. You would then multiply it and tidy up. So that's going to be x squared plus 6x minus 4 is equal to 12. And then that becomes x squared plus 6x minus 16 is equal to 0. And then that factorizes using our sum and product to be x plus 8, x minus 2. I've omitted a wee bit of working out there, which means x is equal to minus 8 or x is equal to 2. Now what we want to do is we want to fire those back into the y's to find the corresponding y values, and that's a bit maybe people forget. So just say when x equals minus 8, y is going to be equal to 3 times minus 8 minus 2. 3 times minus 8 would be minus 24, and then minus another 2, that's going to be y is equal to minus 26. So one of your solutions is minus 8 minus 26. Same idea. When x is equal to 2, y is going to be equal to 3 times the 2 minus 2. So y is equal to 6 minus 2. Just write that down. 6 minus 2, so y is equal to 4. And then the other solution is 2, 4. So there's question 1 done. Question 2, we've got a transformation question. I'm not a big fan of these questions. It says, below shows a sketch of the graph of y is equal to f of x. Point A has coordinate 4, 4. Each of the following sketches shows a single transformation of the function y is equal to f of x. For each function, you use function notation to describe the transformation shown. Okay, right. So what has happened? This point here, A was 4, 4. Let's mark it on to make life easier. And you can see it has moved. It has moved 2 units left. So it's moved 2 units left. So that's going to be y is equal to f of, and if it's horizontal, it's inside the bracket. So it's x plus 2. That's what it's going to be. The next one, this is a vertical, it's reflected vertically. So in this direction, so it's in the vertical motion, vertical direction. So it's y is equal to, and minus f of x is what it should be. The next one, okay, it is moved 2 left, and also it has then been stretched. Oh, has it been stretched at all? What's happened to it here? It has, what have we done here? That should have been 6. So the original graph, let me just sketch this. The original graph was like this. So that was 4, 4. And that was the point 60. So that has moved in by scale factor 2. Yep, that's all it is. Sorry, it's a horizontal stretch, scale factor equal to a half. So it's been squashed in by scale factor 2, or scale factor a half, I suppose, it's been stretched. So that is y is equal to f of, and it is ax, where a is equal to 1 over a half, which means it's equal to 2. So that's y is equal to f of 2x is what that's going to be. Apologies for that one. Okay, right, number 3 says find the exact solutions of the equations. Ln of 2x minus 3 is equal to 4. So exact solutions. Okay, there's 3 things that are happening to your x. Here it is being multiplied by 2, then you're taking away 3, and then you're doing a ln of it. So let's reverse that process. So the first thing we have to reverse is ln. So you do, the inverse of ln is e, so e to the power 4. And then we had to reverse the taking away 2, so that means we're going to add 3, I should say. And your last line is bring that across, that 2 across, and that's what you could have. You could also write that as x is equal to a half upon e to the 4 plus 3. So either of those would work. Next one. Okay, it says when expression x cubed plus px squared minus 2x plus 6 is divided by this, x plus 2, the remainder is 2p minus 8. So this is a remainder theorem question. So that means f, if you divide by this thing, it's f of minus 2 then, is equal to 2p minus 8. We're also going to put the minus 2 into this thing and see what we get. So that's going to be minus 2 cubed plus p times minus 2 squared minus 2 times minus 2 plus 6 is equal to 2p minus 8. And then just go along with that. So that's going to be minus 8. That's going to be plus 4p. And that's going to be plus 4. And that's going to be plus 6 is equal to 2p minus 8. Right, that's a mess. That's tidied up. Left hand side, you've got 4p, sorry. And then you've got 4 plus 6 is 10 minus 8 is going to be plus 2 is equal to 2p minus 8. That means 4p minus 2p is equal to minus 8 minus 2, which means 2p is equal to minus 10. So p works out to be minus 5. So if I've done that correctly, there we have it. P is equal. Okay, for question 4, it says below shows a sketch of a curve and a straight line which intersects at 2 distinct points. Okay, we've got y is equal to x squared plus 3 is your curve, and you can see it intersects at the points 0 and 2. We don't actually need to find the equation of the line for this, because what we can do here is we could find the area of this whole trapezium. Okay, and then we could also find the area just underneath the curve, so this bit, and then we could subtract the trapezium area minus area under the curve to find the wee shaded area. So that's what we need. But to find the area of the trapezium, you will need to find its vertical height at here and here, so these parallel sides. So we need to find, and those are equivalent to the y value of the curve at the point x equals 0 and the x equals 2. So we need to find those first. So I'll just do the working out for this up here. I wouldn't do this in an exam, it's just so you can see it. So we'll just say when x equals 0, y will be equal to 0 squared plus 3. So y equals 3. Okay, so that means this height here, sorry, this pen's not working. This height here is 3. Also, when x equals 2, y is going to be equal to 2 squared plus 3. So that's going to be just 7. So this height here is going to be 7. So we can find the area of that trapezium. So we'll say area of the trapezium. And remember the area of the trapezium formula, it's a half a plus b times h, which is going to be a half times your a, which is one of your parallel sides 3, plus the other one, which is 7, times the perpendicular distance between them, which is 2. Bang that into your calculator, half times brackets 3 plus 2, 3 plus 7, sorry, plus times 2, and then that is just going to give you 10. Okay, so that's the area of the trapezium. Okay, we'll say the area under the curve is equal to the integral between 0 and 2, and it was of x squared plus 3 dx. And if you do that out, you're going to get x cubed over 3 plus 3x, and that's between 2 and 0. And that's going to be 8 over 3 plus 3 times the 2, and then minus the 0. And 8 over 3, what's 8 over 3 going to be? 2 and 2/3. 2 and 2/3. 2 and 2/3 plus 6, so that's going to be just 8 and 2/3. So your shaded area then, remember your shaded area was just equal to the area of the trapezium, which we had worked out as to be 10 minus 8 and 2/3. And if you do 10 minus 8, you will get 2, and then minus another 2/3. So 2 minus the 2/3 is going to be 1 and 1/3, and that's going to be square units, or units squared. Okay. Next question says, write down the first 4 terms in ascending powers of x of the expansion of this thing. So this is using your NCR button. So we're going to say the first term is going to be 10C0 times 1 to the power of 10 times minus x over 2 to the power of 0. And next one's going to be 10C1 times 1 to the power of 9 times minus x over 2 to the power of 1. Your next term is going to be 10C2 times 1 to the power of 8 times minus x over 2 squared. And your next one is going to be 10c3 times 1 to the power of 7 times minus x over 2 cubed. And then whatever that works out to be. So the first one, 10c0, get my calculator here, 10c0 is just going to be 1. 1 to the power of 10 is just going to be 1. Anything to the power is just going to be 1, so that's going to be 1. Next one, 10c1 is 10. And then 1 to the power of 9 is just 1. And then that's just minus x over 2. We'll have to tidy this up in the next line. Calculator needed then, 10c2 is 45. So that's going to be 45 times 1 to the power of 8 is just 1. Minus x over 2 squared becomes minus x times minus x is positive x squared. 2 squared is 4. And your last one is 10c3 works out to be 120. Did that in my calculator. 1 to the power of 7 is 1. And then minus x cubed over minus x over 2 cubed will be minus x cubed over 8. And so on. And then we'll just work these out. So the first term is definitely just going to be 1. 10 times minus the half will be minus 5x. Then we'll just work that out. 45, well, actually, we'll just leave it as 45 over 4. 45x squared over 4. I think that's as nice as anything. The next one will cancel down a wee bit. We have 120 over 8, which is just 15, and it's going to be minus 15x cubed. Have we done the answer to the question? First 4 terms, done it. Happy days. Okay, question 5 says, a position for 3 towns A, B and C are shown in figure 3 below. So this is a bearings question, and you've got B is on a bearing of 0, 4, 0 from A, and then C is on a bearing of 0, 7, 2 from B. The first question says, find the obtuse angle ABC. So the obtuse angle ABC is this angle in here. So by basic parallel lines, this angle in here is co-interior angle to the 40 degrees. So this angle, first of all, I'll label as being 140 degrees. And then that means my angle B, I can just do the working out down here. The angle, ABC, the obtuse one, is 360. Remember the angles at a point or make up a full turn, so 360 degrees, minus 140 minus 72. So that works out to be 148 degrees. Okay, the next part of the question says, find the area of the triangle ABC. So if you imagine, I linked this up, and there's my triangle ABC. So I've got this side here. Oops, no, is this not written? This side here, I know is 17. This side is 25, and they've got their included angle. So you're using the fact that the area of the triangle is a half AB sine C. So I'm just going to draw that wee triangle out again that we had. That was 17, that was 25, and the angle between them was, what have I just worked out? 148. So that's really what we're doing, how we're using that, because again, we've got a side, and their included angle. So half AB sine C. So you just fire that into your calculator, half times 17 times 25 times sine of 148. Fire that into your calculator, and what I got was 112.6078, and checking on the front of the question paper, it said give answers to 3 sig figs, so 113 kilometers, and that's the 3 sig figs. But I would keep this in as part of my workout. I would definitely show that, and you'll see me doing that in the next part of the question as well. Next part of the question says find the distance AC. So remember, that was my point A, that was my point B, and that was my point C. So the distance AC, we're going to use the cos rule. We're going to use the cos rule. This thing would let me write. And we're going to say A squared is equal to B squared plus C squared minus 2BC cos A. And we're just going to fill that in. That means A squared is equal to 17 squared plus 25 squared minus 2 times 17 times 25 times my cos of the angle 148. When I worked that out, I got A squared to be equal to 1,634.840882, and then I meant my A was 40.43317. So again, the 3 sig figs, that's 40.4 kilometers to 3 sig figs. Okay, the next and the last part of this question, it says for us to find the bearing of A from C. So, bearing of A from C, let's see what we're actually looking to get here. So let's get rid of a few of these wee markings. The bearing of A from C, we want to, first of all, I would draw another north line here, so parallel to the other ones obviously. And if that's 72, then this angle, you could work that out as 180. 180, why is this not letting me write? 180 minus 72, and that's going to be 108 degrees then. So that's what that angle in here is going to be. And we want to find the bearing of A from C, so we want to find all the way around to here. But we need to know this wee angle. So this wee angle is my angle C. That's what that angle in here is. So we need to find the angle C of the triangle. So we're going to go back and we're going to have to use our sine rule to do this. So remember what we've got so far. You've got your, that was 17, then that was 25, that was 148. That's what we're looking for. That's our angle C. And what else do we know? We had worked out as well that this side was 40.43317. So to get your angle C, I'd say sine of angle C over its opposite side, which was 17, is equal to sine of 148 over its opposite side, which the whole pile of decimal places was 40.3317. Okay, now if I multiply across by the 17, I'll have 17 times sine of 148 all over 40.43317. And then also, if I do sine to the minus 1 of that whole thing, I will get my C. So a wee bit of working out, I fired that in my calculator and I got 12.87371. And then the bearing, I'll go back to my diagram from earlier on. The bearing, where are we? This one, I think it was. Yep, the bearing was this whole angle all the way around to here. So it's 360 minus the 108, and also that angle, that wee small angle, which we've just found in here, this wee one in here, so that was our C, we called it. So we need to do our bearing then to be 360 minus that 108 and that 12.87371, which we just worked out. And when we did that to 3 sig figs, what I got was 239 degrees to 3 sig figs. Okay, that's that part of the question done. Still in angles question, still a trig question. Part B of it, we're doing this, we're finding this, solving this, I should say, this question. Okay, first of all, we've got sines and tans involved here. I'm going to write my tan, I should say, as sine x over cos x plus 2 sine x is equal to 0. Then I'm going to factorize out a sine, and that leaves me a bit of a mess, but that leaves me 1 over cos x plus 2 is equal to 0. Now we're in this lovely stage of mathematics where you've got a times b is equal to 0, and that can happen when a is equal to 0 or when b is equal to 0. So here we're going to put the first thing, sine x equal to 0, and then we'll do it over here. We also have 1 over cos x plus 2 is equal to 0. So we'll sort out the sine x equals 0. So people think you can't use the cast diagrams for these, but you absolutely can. Think about what angle would give you 0. So sine of 0 would give you 0, so that would be here. So that means the opposite place as well, 180 degrees would also give you 0. So you add 0 degrees and 180 degrees. And also look at the range. It was 0 is less than or equal to x is less than or equal to 360. So you're allowed to be 360. So that's back to this place again. So you've got 3 angles from this one result here that sine x is equal to 0. Okay, didn't really have to use cast diagrams too much there, but we're going to have to do it for this one. Bear with me a wee second. I'm going to, first of all, I will say 1 over cos x is equal to, file the 2 across, it becomes minus 2. And then 1 is equal to minus 2 cos x. Wee bit of rearranging, you're going to get cos x is equal to minus 1/2. Basic angle. So how you do your basic angle, you do shift and cos of just 0.5, ignore the minus. And when you do that, you get 60 degrees. And then your cast diagram, see A, S, and T. There's your 0. That's the only thing I ever mark on. And cos is negative. So now you're going back to this thing, the fact that cos was negative. So it appears in the S and the T. And your 60 goes with the horizontal. So my first angle is 120, and the next one's going to be 240. So from here, you'll get 120 degrees and 240 degrees. So sum up your answers, just to be nice to the person marking it. 0 degrees, 120 degrees, 180 degrees, 240 degrees, and 360 degrees. Okay, next question is a vectors question. It says OA is I minus j, OB is 3i plus qj. Find, in terms of q, the vector a to b. So a to b, first of all, is your o to b minus your o to a. So that is, let's just write that down, that's 3i plus qj minus I minus j. So if we sort that out, that's going to be 3i minus I is just 2i, that's easy enough. And then you've got qj minus minus is plus j. So really what you have, let's just write that as 2 times vector I plus, and then you've got q plus 1 times your vector j. So that's as good as I can, as pretty as I can make that. Next thing says, I missed it, there we are. It says AB has a magnitude of 3 units. So let's just write down what we had got from earlier on. We had found out that AB was equal to 2I plus Q plus 1J. That's what we have. And we now know this thing has a magnitude, a size, a length of 3 units. So what does that mean? That means 3 is equal to the square root of the 2 squared plus the Q plus 1 squared. And then square both sides, and you're going to get 9 is equal to. And then square that 2, you're going to get 4. And square the q plus 1, you're going to get q squared plus 2q plus 1. Bring everything over to one side, tidy up, you're going to get q squared plus 2q minus 4. When you bring that 9 across, 4 plus a 1 is 5, and then minus a 9 is minus 4, yep. And then this is a quadratic equation. Now it says in this, find the possible exact values. So when it says exact, they're going to mean leave it in terms of surds. So minus b plus or minus my b squared minus 4 times my a, which is 1 times my c, which is minus 4, square root of all that, all divided by 2a, which is 2 times 1. And if you tidy that absolute mess up, you're going to get minus 2 plus or minus, that's going to be root of 20 all over 2. I tidied that up again. Minus 2 plus or minus root 20, if you fire root 20 in your calculator, you're going to get 2 root 5. It's all divided by 2. So that means q will be equal to minus 1 minus root 5, or q will be equal to minus 1 plus root 5. And there we have it. Okay. Next part of this question. I don't know why this is labelled part B, why it's not a separate question. It says find a range of values for k for which the equation x squared plus brackets k minus 3 upon x, so 3 minus 2k is equal to 0 has 2 distinct real roots. So that means 2 distinct real roots means b squared minus 4ac is greater than 0. So your b here is k minus 3, your a is 1, your c is 3 minus 2k, and that has to be greater than 0. Let's just work through that. So let's sort out the k minus 3 squared. First of all, that's k squared minus 6k plus 9. Then over here, minus 4 times 1 times 3 is minus 12. Minus 4 times 1 times minus 2k will be positive 8k, greater than 0. That's a mess. Tidy it up. You're going to have k squared plus 2k minus 3. Is that right? It is greater than 0. And I would just say let k squared plus 2k minus 3 equal to 0. We want to see where this crosses the axes, where it has roots, basically. So that would factorize to be k plus 3 upon k minus 1 is equal to 0, which means then k is equal to minus 3 or k is equal to plus 1. Now we're going to do a sketch then. So sketch, just to keep it all here, sketch is like this, crosses at -3 and it crosses at 1, and then you look back at your inequality. We wanted it to be greater than 0, so that means we want out this way, or we want out this way. So we want our answers. We want k to be less than -3 or k to be greater than +1. Okay, 3 more questions to go, I think. Right, lovely question here. We've got a rectangular sheet of metal is shown, and it says the sheet has a length of 15 units and 8 wide. 4 squares are cut out from the corners, and the box is then formed by folding up the edges. So if you can imagine, this bit here, this length here from here to here is going to now be 15 minus 2x. This length from here to here would be 8 minus 2x, and then it's going to have a bit of a vertical height. So that's really what's going on here. You can see why I'm not an art teacher, but that's what's going on. So the height of it is x. One of the lengths, the long length here, is going to be 15 minus 2x, and this length, I'll label that slightly differently so we can see that. So this one here is going to be our 8 minus 2x. So you've got the volume is going to be 8 minus 2x upon 15 minus 2x upon x. That's what it's going to be. So the question then says, show that the volume of the box is given by this. So volume again is x upon, what have I just said, 8 minus 2x upon 15 minus 2x, and then just multiply this out. So it's really an expanding 3 brackets question, and one of your brackets is very easy, so it's just x. So just do 8 times 15, you'll get 120. 8 times the minus 2x, you get minus 16x. Minus 2x times the minus 2x times the 15 is minus 30x. Minus 2x times minus 2x is plus 4x squared. We'll tidy that up. It's a bit of a mess. That's just going to be x upon 120 minus 46x, I should say, minus 46x plus 4x squared. Multiply out and you will get 120x minus 46x squared plus 4x cubed, and then that means your volume is equal to 4x cubed minus 46x squared plus 120x, and that's it done. Okay, let's write that down again here. We're going to need that in a wee second. What was that? 4x cubed minus 46x squared plus 120x. It says, using calculus, find the value of x for which the volume is a maximum. So this is going to be calculus, and well, they've given us that clue anyway. dv by dx, differentiate this thing, you're going to get 12x squared minus 92x plus 120. That's what you get when you differentiate it. To find where there's a maximum, first thing you've got to do is put dv by dx equal to 0, which means 0 is equal to 12x squared minus 92x plus 120. Now this actually factorizes I say nicely, it factorizes in some way. I didn't see how it factorizes quickly. I wouldn't waste your time in an exam trying to factorize this quickly. I would just use a quadratic equation. So xn is equal to minus of b, so positive 92, plus or minus, that's my b squared, minus my 4 times my a times my c, which is 120. Square root of all that, all divided by 2a, so that's 2 times the 12. And when I did that out, I got x is equal to 5 over 3, which is the same as 1 2/3, or x is equal to 6. Now let's think about this. The second one here, x equals 6. Imagine if x had been 6 here. This length would have been 6, this length would have been 6, but together that they would have added to 12. So there's absolutely no way that this side could have been 8. So 6 is not possible. You don't need to explain it. Just say not possible. Okay, so this is our answer, but just to be guaranteed getting the full marks, you've also got to, because we're trying to show what was maximum, you've got to do dv squared by dx squared, and when I did it, I got 24x minus 92, and just say when x is equal to 1 2/3, d2v by dx squared worked out to be minus 52, which is less than 0, which implies that it's maximum. Okay, so we'll read the question again. And when I look back, it did say, using calculus, find the value of x for which the volume of the box is maximum. It didn't ask you to find the volume, so you don't have to do anything else. Okay, getting there. Skip past this one. There we are. That was a blank page there. Right, next one says, show that f of x is an increasing function. So for an increasing function, basically an increasing function is something along the lines of that, where it's all the gradient is always going up. Okay, so it's always got a positive gradient. So we want to find what the gradient is. So first of all, what we're going to do is get our f of x in index form. So x cubed over 3 plus 4x minus 4x to the minus 1. Then we're going to differentiate it. So when you differentiate it, you're going to get 3x squared over 3 plus 4, and then plus 4x to the minus 2. And then we could tidy that up a wee bit. That's f dash of x then is equal to x squared plus 4, and then plus that would be plus 4 over x squared. Now, you can look at this lots of different ways of doing this. So I'm just going to look at the individual bits. So I've got x squared, 4, and I've got the 4 over x squared. Now, x squared is always positive. The 4 is always positive. Okay, right, first of all, then explain. Your x squared is always positive because no matter what value you put in, it's always going to be, put in a minus number, minus times a minus is positive, put in a negative number, minus times minus positive. Put in minus numbers going to be positive, put in positive numbers going to be positive. Likewise, your 4 over x squared is always positive as well. Okay, so that means, therefore, that means your f dash of x is always going to be greater than 0. That means it's going to be, therefore, it's an increasing function. Okay, 2 more to go. Okay, right, this next question, not overly nice at all. I looked at it and thought this was going to be nice enough, but it's not. You can waste a lot of time, and I know when I did this out the first time, I did waste a wee bit of time doing something which I didn't need to do. So first of all, it says 2 straight lines are given by the equation, and you've got these 2 equations. Call these equations 1 and 2, and we'll be referring back to them. And as I always say to people, once you find an unknown, once you find a constant, then rewrite your equation, otherwise it gets very confusing. Now it says 2 straight lines are given by these equations, where P, Q and R are constants. The lines intersect at this point. So this point satisfies both of these equations. It also tells you the lines are perpendicular. And then what you've got to do is you've got to find the area enclosed by the 2 lines and the positive x-axis. Right, first of all, we've got to find P, Q and R. So first thing I'm going to do is I'm going to sub the point minus 2, 3 into equation 1. There's lots of different ways of doing this. I'm well aware of that. So we'll just, if you have a better way, good for you. 4 times minus 2 and plus 3 times the 3 is equal to P. So straight off, that can tell me 4 times minus 2 is minus 8. 3 times 3 is 9. Minus 8 plus 9 is just 1. So you've got your P is equal to 1. So therefore, your equation is now 4x plus 3y is equal to 1. That's my new improved equation 1. So if I'm using equation 1 again, that's what I'm going to use. Okay, what I'm also going to do is it tells me this wee bit of information that the lines are perpendicular. The lines here are perpendicular, so that means we know one of their gradients is a negative reciprocal of the other. It's a wee bit awkward to find their gradient, so what I'm going to do is rearrange equation 1. So I'm going to say 3y, first of all, is minus 4x plus 1, which means y is equal to minus 4 over 3x plus 1/3. Now, that's my new improved equation 1. All of that is going to be important. So the gradient of this thing, but first of all, is equal to minus 4 over 3. I'm also going to rearrange, if I could write, rearrange my equation 2. So my equation 2, what was it? Qx plus 2y is equal to r. I'm going to rearrange it to say 2y is equal to minus, where have I done this? Qy is equal to minus qx plus r. And then I'll divide across by the 2 to give me y is equal to minus q over 2 x plus r over 2, and that's my equation 2. And it has a gradient equal to minus q over 2. Now, these two gradients, come on, why will it not let me do this? These two gradients here, minus 4 over 3 and minus q over 2, are perpendicular. Just say perpendicular. So that means that we'll say minus q over 2. It's a negative reciprocal of this one up here. So negative reciprocal, that thing, make it, so that means flip it upside down, change its sign. You're going to have 3 over 4. And then I'm going to multiply across by the minus 2, and that will give me minus 6 over 4, which is the same as my q being equal to minus 1.5. Okay? So what have I got now then? So I could rewrite my equation 2 is now going to be minus 1.5x plus 2y equals r. Minus 1.5x plus 2y is equal to r. That's my equation 2. So my new improved equation 2. Okay, right. What do we also know then? We also know that we're going to now sub the point, and what was our point? Minus 2, 3 into equation 2. So it's going to be minus 1.5 times 2 plus 2 times my y, which was 3, is equal to r. So we better working out what's that going to be. That's going to be minus 3 plus 6 is equal to r. Apologies, I made a mistake here. That should be minus 1.5 times minus 2. So that's minus 1.5 times minus 2 would be positive 3 plus 6 is equal to r. So r works out to 3. So r works out to be 9. So 3 plus 6 is 9. R works out to be 9. So we could rewrite our equation 2, and we're going to use this version of equation 2 up here. I should have used that earlier on. So we'll use this version up here for my equation 2. So equation 2 is now going to be y is equal to, and it was, bear with me, sorry, minus q over 2. What was our q? 1.5. So that's going to be minus 1.5 divided by 2. Sorry, well, I've lost my place. What was my q? Q is minus 1.5. Minus 1.5. So it's going to be minus of minus 1.5 over 2 times my x plus, and then it was 9, my r, which is 9 over 2. So that my y is going to be equal to, and that's going to be yeah, that's right. So I'm just checking that. I made a wee mistake in this earlier on. 3 over 4x plus, and that will be 4.5. Okay, right. Now that is my equation 2. I'll write down what my equation 1 was from earlier on as well, wherever it was. It was minus 4 over 3 x plus 1/3. And that was my equation 1. Okay, now these two lines, what the question asked us to do was find the area of the triangle bounded by these two lines and also the point which was minus 2, 3. So you've got, that's where those two lines intersect. one of them cuts here at 1/3, the other one cuts here at 4.5, and the distance then is 2, so that's 2 units. So to find the area of the triangle, we've got a base here, which I've just drawn on. We've got a height of 2, and we want to find the area of this triangle. So the area, remember, is a half times the base times the height. So that's going to be a half times the base. The base is just going to be 4.5 minus 1/3, and the height is 2. So if you do that, it's really just going to be, well, let's just do it out. 2.5 times 4.5 minus 1/3, and then times the 2. And I got 25/6, which is 4 1/6 units squared. 4 1/6 units squared. Okay, so a tough question. I think it's as difficult as you're going to get really at AS level. Right, next question says, given that 1 over root of A plus 1 is equal to root P plus root Q, find in terms of A an expression for P and Q. Right, forget about this for a minute, and what we want to do is rationalize the denominator. That's really what this question is. So we'll write it over as 1 over root of A plus root of A plus 1. And all we're going to do here is rationalize the denominator. So how you do that, we'll write the thing out again. And then times top and bottom by root of A minus root of A plus 1. Now, this is it actually turns out very nicely. You've got root of A on the top. Multiply 1 times the root of A minus root of A plus 1. That's what you get on the top. And on the bottom, and people find this difficult, but you shouldn't find it difficult if you learn this result. What you've got on the bottom is x plus y upon x minus y, with your x being root A and your y being root of A plus 1. And that identity tells you if you do it out, you'll get x squared minus y squared. So that's the difference of two squares. So really, what you're going to get is A minus A plus 1 on the bottom line, and then that works out to be, sort out that bottom line, you're going to have A minus 1. Top line is root of A minus root of A plus 1, which really is root of A minus root of A plus 1 all over minus 1, which then you can sort that out, and that's going to be minus root of A plus root of A plus 1, which, to write it their way, is root of A plus 1 minus root of A. So they had told us this was the same as root of P minus root of Q. So clearly P is equal to A plus 1, and your Q is equal to just A. And our last question, thankfully, it says, hence or otherwise solve this thing. Now this thing we have now just said, this is the same as root of A plus 1 minus root of A. And then what we have over here is root of 4A. Root of 4A is the same as root of 4, which is 2 times just the root of A. So it's a wee bit of understanding of surds and how they work. So then bring that root A across. You're going to have 2 root A plus another root A, which is going to be 3 root A. And then what you could do is square both sides. So if you square both sides, you're going to get A plus 1. And square the 3, you'll get 9. Square the root A, you'll get A. Then bring the A across, you'll have 9A minus A. And then you'll have 1 is equal to 8A. And then you'll have a wee bit of working out. A is equal to 1 over 8. And that is it. And just check your last page. This is the end of the examination, so you know you're finished. So go back and just check over your work.